All right, let's just dive right into this explainer and absolutely demystify Run CPU. If you're working with SPEC CPU 2017, this is literally the primary tool you'll be using to drive benchmarks right from your command line. So if you want to accurately measure your system's performance, mastering this is totally non-negotiable. Let's break down exactly how this powerhouse of a utility works.
Here's our roadmap for today. We're going to meet the run CPU command, master the basic syntax, look at the benchmark run order, tackle managing massive disk space, discuss multi-user sharing strategies, and finally, go over essential cleanup actions.
Okay, Section 1. Let's meet the Run CPU command and get you started with SPEC CPU 2017. We're going to start with a beautifully simple command. Check this out. By just typing Run CPU, followed by a target benchmark name, like 519.lbmr right here, you're telling the system to handle the whole shebang. It automatically tracks down the source code, compiles it into an executable, and runs that specific test. It's really the perfect low-risk starting point if you're a beginner, just checking to make sure your installation is actually working. Moving right along to Section 2, Mastering Basic Syntax. Let's look at options, suites, and tags.
Now, what if you want to scale up? Well, we can easily tweak that base command. Instead of a single benchmark, we just add an option flag, like --copies equals 64. And instead of one test name, we specify an entire suite, like fprate. Just like that, this single line of code tells the system to run 64 concurrent copies of every single floating point rate benchmark in that suite. Talk about a massive jump in scale, right?
When you are scaling up, you basically have four main suites to choose from. The speed suites, that's intspeed and fspeed, are entirely focused on single copy time. The whole goal is just getting the task done in less time, period. On the flip side, the rate suites, intrate and fprate, they measure throughput. They're asking how much total work can we get done over a specific period of time. And to figure that out, it requires running multiple concurrent copies all at once.
So the absolutely crucial takeaway here is knowing exactly which flag to use. If you're running a speed suite, you're going to use the --threads flag to speed up a single job using OpenMP threads. But if you're running a rate suite, you use the --copies flag. That pushes way more total concurrent jobs through your hardware at the same time. These are two totally different ways to stress test a machine.
Next up, Section 3, the benchmark run order, or the anatomy of a reportable run.
Let's say you want to officially publish your results. To do that, you have to add the --reportable flag. By typing run CPU --iterations equals 3 --reportable followed by your suites, you're basically forcing the tool to enforce the official spec run rules. It turns off informal testing mode and ensures your run is strictly compliant, no cutting corners. And when you execute that reportable command, your system locks into this really strict four-step sequence. First up is the test phase, which just quickly makes sure the compiled code actually gets the right answers. Second is the train phase, doing the exact same thing but with slightly larger workloads. Notice neither of these are timed. Then third, we hit the ref phase. This is the main event. It runs the reference workloads for multiple iterations with strictly timed measurements. And finally, the report phase crunches the numbers to compute your median times and generate those official metrics. All right, Section 4. Let's talk about managing massive disk space, or what I like to call the aftermath of a run.
Now, I absolutely love this. Hey, where did all my disk space go? That is an actual direct quote from the official manual. Why? Because it is a moment of sheer panic that literally almost every beginner experiences right after their first massive benchmark run finishes.
Here's the deal. The vast majority of your disk space gets swallowed up by the automatically created run directories. When you fire off Run CPU, the system copies these incredibly massive datasets into the run folders so it can perform the benchmark safely without messing with your original source code. Sure, the build folders, executables, and log files take up a little space too, but those run directories, they are the primary culprits for your suddenly missing gigabytes.
Which brings us to Section 5, multi-user sharing strategies, or how to play nice on the same server.
So if you're sharing a server with other people, you've got a couple of choices. The manual points out a partial solution called --xbid, which creates nice little subdirectories for your results. But here is the massive catch. The core tree is still writable by everyone. That means someone else could totally overwrite your files by accident. So the highly recommended, completely bulletproof solution is --output root. This lets admins lock down the main tree so it's read-only and dynamically routes all of your specific output right into your own personal directories. By dropping that output root flag into your command line, you're essentially handing yourself a private sandbox. It guarantees that nobody accidentally trashes your hard-earned benchmark results. And as a really nice bonus, you won't inadvertently corrupt the main installation while you're running your own complex tests either. It's a total win-win for everyone on the server.
And finally, Section 6, Essential Cleanup Actions, or how to actually get your gigabytes back.
To reclaim your storage, we use the --action flag. Take a look at this command. Run CPU--action equals clean fprate. Normally, the default action is always just to build and run, but by explicitly setting it to clean, we are totally changing the fundamental behavior of the tool. We're telling it, hey, stop compiling, stop reporting, and start taking out the garbage for the fprate suite.
Now you actually have 4 different levels of cleaning. Clean just empties out your specific run and build folders. Simple enough. Clobber takes it a step further and actually removes your executables. But listen up, you need to be incredibly careful with trash and scrub. Why? Because those aggressive commands wipe out directories for all users on the entire system. Oh, and a massive warning straight from the official manual. If you try to test these destructive commands using the --fake dry run flag, the cleaning will still actually happen. Fake mode does not protect you from deletion, so watch out.
All right, you are now equipped with the exact command line steps to confidently navigate Run CPU. From running your very first basic test, all the way to a full reportable run, and finally safely cleaning up the aftermath. This really opens up an entire world of performance testing for you. So, the only question left to answer is, what hardware are you going to benchmark first?